Greetings, my name is Rodney Kawecki, and I specialize in writing about physics, particularly in the area of relativity theory. This field of study is currently one of the most significant in the scientific world, primarily due to its focus on the concept of a universal speed limit, the speed of light. Recent research has provided compelling evidence that the space field, often referred to as dark matter, observed in the night sky, is characterized by its low-density nature. According to the renowned physicist Albert Einstein, space can be likened to a glass filled with water, with a surface serving as a dividing line within the space. This surface is seen as a representation of the expanding universe, much like the water level in a glass. In this analogy, the expansion of the universe can be visualized as the process of filling up a glass with water, with the surface acting as a boundary between the familiar space we inhabit and the uncharted territories lying beyond.
The vast expanse of space can be likened to a boundless ocean, with us situated at its midway point, surrounded by an endless sea of darkness. According to the Hubble theory, this space is like an inflating balloon exerting a force on dark matter, causing the Hubble sphere to expand at a constant velocity. Despite this velocity surpassing the speed of light, at 43 miles per second, it acts as a driving force pushing galaxies further apart. The concept of low-density space implies a field composed of extremely light elements, such as particles as minuscule as stains or as weightless as air in feathers.
The amount of energy needed to propel galaxies away from each other at a consistent pace is substantial, reaching 450,000 miles per second squared. This energy is determined using the formula E=mc², with c denoting the speed of light. Within galaxies, there are planetary bodies, stars, and entire solar systems residing within the bounds of interstellar space. The Casimir effect pertains to the peculiar scenario in which two positively charged plates made of metal or electromagnetic material are positioned close to one another, yet still possess some separation. Isaac Newton's principles outlining motion and gravitational forces serve as a means to elucidate the intricate movements of celestial entities within galaxies.
Isaac Newton's theory in Newtonian physics posits that similar matter does not always completely connect, leaving space between them akin to two positive magnets repelling each other. This space was discovered to be empty vacuum space instead of being filled with negative energy, as originally thought. It is conjectured that as planets and other moving matter produce energy, this positive energy generates a flow in the space between them, resulting in a central negative flow of energy within the empty vacuum space field. The interaction of this energy between matter and particles gives rise to a repelling force, contributing to the dynamic nature of the universe.
According to the theory, a balloon is said to exert a significant amount of pressure on the fabric of space, causing ripples to form near the Hubble sphere. These ripples expand and accumulate energy over time, creating a unique phenomenon known as the Hubble anomaly. It is believed that this anomaly serves as the driving force behind the expansion of the universe. If one were able to harness this seemingly infinite source of energy, they would possess unimaginable power capable of potentially reshaping the very fabric of existence itself. The implications of such power are profound and could have far-reaching consequences for the future of the cosmos.
Hello. Back again. I just wanted to show you that picture of what the universe might have looked like at the time of the Big Bang. To any degree, it's a big star. That's what it is, one big star. Going back to about my video you just looked at, I've researched physics for quite a while. And I kept on wondering what they're teaching in the universities. They're teaching relativity. There's other physics, biology and all that stuff. And parts of other physics from other people. Okay. But anyways, I've read quite a few books on physics. And my inquiry as an update to my other videos is the idea of dark matter or dark energy. I did some research on dark energy, and it seems that dark energy is considered a low density field. What I mean by low density means energy. It has no energy in it. It's empty vacuum. And that's exactly what it is. But what I researched, I found in Alcubray warp drive, negative energy. Now, when you start a car, you have a battery, positive energy, right? I showed it in this video. They showed a car and it starts the car, but it won't start if you disconnect the negative energy. Am I correct? So let's apply it to my theory. Everything in the universe is positively charged. It's positive matter. Uh, Aside from that, we have what's called the Hubble sphere or anomaly. It's a big round like balloon expanding space. As it grows, it gets bigger and it expands the space. It pushes galaxies apart. Slowly but surely, but that's what happens. So I started thinking if all the uh, galaxies, stars, planets, solar systems, and everything are positive energy, and according to Newton's law, positive energies repel. That means you you can't put them together without. They're like having two uh, positive poles or two negative poles on a magnet. They repel. They won't go together. And the harder you push it, in the center, there's always going to be some space. That's called the Casimir effect. But what is that energy? They never found out. But we can conclude that it's negative energy. We have two positive poles. We have trying to push them together because they attract each other, but they repel. So we have a separation. We have space between the galaxy, stars, and planet. That's how it works. But now we have another problem. We have the sphere, the Hubble sphere, that has a repulsive force and is increasing the space between galaxies, for a starter. Now, all the galaxies, all the planets and stars inside the galaxies, they are also, the space is also expanding, but at a probably a very, very small rate, if any. It's like the two uh, magnets, positive magnets being so close together that it doesn't do nothing. They can't go any further. So let's make that assumption. Matter's not increasing. It stays the same. But matter, or planetary matter, galactic matter, stars, solar systems, they put out energy to keep this the way it is. They get excited. It's called excited or excitation due to the movement. Now it's causing the movement. Newton's law says that it's the accumulation of the group of positively charged planetary matter acting the way it should as they're together, as they are in a group. But we also has a repulsive push force. A repulsive push force is greater than light. The pressure. I'm not talking about the mileages. 43 miles a second is the Hubble rate. That's how much the universe expands. I'm talking about the energy it would take to do that relative to the universe. Einstein says everything's the speed of light. In 1925, when Hubble discovered it was expanding at a rate faster than light. So we have a monopoly there. We have an argument between these two theories. Now, if it's expanding at 43 miles a second, how much energy would it take to push these galaxies apart? I've did some more research going way back and discovered that it's about twice the speed of light, maybe a little bit more, because the thing keeps growing, keeps getting bigger. The expansion gets more and more over time. And how I got that was the energy it takes, the power it takes is 450,000 miles a second squared. You square it, you're going to get an energy content, a sum. So this is pushing on space. It's also expanding the universe, or it is expanding the universe. Now, if planetary matter or the galaxies, even the space between galaxies, are pulsating energy, what's happening in space? There's space between all this matter, all this universe matter. It's positive energy is pulsing a density in space, which is low density, so it's negative energy. Now, this negative energy reads, they know by their measurements, zero, almost a perfect vacuum. And it's a vacuum. What does vacuums do? They suck up stuff. So what's happening to the universe? It's aging. It's getting older and older. The energy is being sucked out by some positive or negative force. So I tried to put one and two together. I don't know if you've already done it, but the Hubble anomaly has to get its energy from somewhere. And it's pushing on space. Maybe it's too much energy that it's getting. And it only can absorb so much energy. So it's pushing it back into the universe. So we have a low density revival between all the planets and stars. Not only is this anomaly sucking in energy, because dark energy is a vacuum, but it can only do it so much. It only can absorb so much of that energy, that negative energy. So it grows, it gets bigger, and it expands the universe. That's what I'm talking about. Now, I've been studying physics on my own. So in other words, I'm not going to the university and learning something that they want me to learn. I'm learning on my own. I don't have my only ambition and to trying to study physics is my books. And relativity and the other scientists claim that this is a low density dark energy. But it holds up planets and stars and galaxies. They don't fall. According to low density, if something's heavy, it's gonna fall. So that points me to negative energy. That anything in the universe is not as heavy as it's supposed to be, because its energy is constantly being absorbed by the negative energy that it produces. And the pressure it's under due to the Hubble sphere or the expansion of the universe is great. So it absorbs this energy, it's in space, and what happens? Weightlessness. We have weightlessness in space, 0 point energy. Right now, accordingly, looking at this university index or text information, they can't prove that it's a negative uh, energy that is dark matter, dark energy, or dark space, the element of space. But everything seems to point towards it. All the experiments done in physics are done under densities, different densities, raising the density, raising the polarity to see what kind of changes take place. That's part of physics. But I'll leave that open for you to conclude. So, my name is Rod Kowicki. Check out my books. You'll be reading something that ain't at the universities. In some point it is. Well, thank you. You're welcome. Wow.